Hello everybody, my name is Adalberto Simeone from the K11 and welcome to my talk about Immersive Speculative Enactments. Let's take a step forward. In the year 2222, if Kai is still alive, we may find a paper titled like this. If we take a positive view of humanity's progress, we could imagine having established human presence in the solar system or even beyond. In this future, then it's not far-fetched to imagine that people will want to communicate across such vast distances. However, we are still in the year 2022 and this is unfortunately still beyond our means. But what if we could stage such a study right now? Could we convince participants that they are really on Mars? Will the results and insight we find be transferable to the real world when the day finally comes that people are going to communicate across the solar system? Research on speculative methods in SIGCHI might help us reach an answer. In recent years, we have seen an increased attention over methods that look at possible or alternate futures. However, the main limitation of these speculative methods is that there are limits to what is possible to achieve through imagination alone or by building tangible props in the real world. Immersive technologies such as VR can help us making these possible futures be more real, more believable, more tangible. In VR, we are not bound by technological limitations. The future we imagine can be depicted in its truest form. Not only can we define all aspects of a speculative technology, but we could also create a context in which said technology will be used and have complete control over it. Indeed, in recent years there have been various examples that try to leverage the use of virtual reality to stage studies or simulate hypothetical situations. Please refer to the paper for a more exhaustive overview of these works. So what do immersive speculative enactment bring? Well, ISEs, for short, do not define a strict process. We rather hope that it will be the community to affect and shape how they evolve as a method. Here we propose our own vision for them and what we think differentiates them from other methods. First of all, why? The core idea behind ISEs is to leverage the immersiveness of VR to live rather than imagine a possible future. We think that if we can make that experiences as believable as possible, then we could use ISEs to gather actual insights that could inform today the design of the technology of tomorrow. To achieve this goal, we created 4 ISEs where we explored another of the core ideas behind ISEs, that they should allow participants to be free to interact with everything they see and not railroad them towards a predetermined set of interaction. Third, we see ISEs as a sandbox type of experience, which should allow participants to see the consequences of their actions, where in conventional enactments, imagination can overcome some of these aspects. In VR, everything must be planned for. For this reason, in the creation of our ISEs, we explicitly accounted for failed states or situations where users did not engage with the speculation. So we designed 4 ISEs, each having higher degree of technological uncertainty. We started from the rightmost one, set in the far future, and used the insights to refine and plan the other 3, which were then executed in parallel, all by independent research teams. The first ISE, Virtual Parent, does not introduce any kind of speculative technology, but rather it focuses on a speculative situation. What if we recently became parent of a newborn baby? This is not something we could easily investigate in an actual study because of the ethical implication. The ISE was set in an environment depicting a studio apartment. Participants had to perform various chores like cleaning dishes, all the while caring for the baby, like preparing their food. In the meantime, the baby had a tendency to endanger itself, like trying to exit the apartment or playing with objects that could be dangerous. 20 participants took part of this ISE. The main takeaway of this experience, as suggested by interviews, was that many participants said that although the ISE was a condensed exaggeration of life as a parent, it led them to rethink how life would change if they had to care for another human being, all while managing their own life. In cross-reality lectures, we imagined a near future where a mixed reality headset could be used effectively to help instructors lecture in front of a blended audience. That is, one where physical and remote students could both be present in the same room. This ISE thus attempts to answer the question of how to represent the remote audience. We designed 3 alternatives. Here you see on your left the abstract avatars and on the right photorealistic avatar. The other 2 conditions were represented by stylized avatars in the top right, similar in appearance but more cartoon-looking than the photorealistic avatars you saw previously. And finally, a baseline condition represented by an all too familiar video conferencing call user interface. And the results show that a preference towards the use of stylized avatars as opposed to the other alternative. So from this perspective, the ISE was able to inform us on potential design choices of such a device. In smart dog monitoring, we focused on a comparative study of 2 visualization modalities for a future device that is able to use machine learning techniques to visualize the needs of a pet. Like in the first ISE, participants had to perform some chores while caring for the dog. Participants tried both devices in a within-subject test, and we used the eye tracking data from the VR headset to log users' fixations to understand where participants looked. Results showed that the participant looked significantly quicker at a notification where they were displayed on the user's watch. And with a postcard from Mars, we come back to the beginning. In this ISE, participants played the role of civilian professionals tasked with routine maintenance on a research outpost. They were divided in two groups, one on Mars and another on the Moon. The task required them to go outside and interact with a panel to repair an antenna, after which they would need to inform Earth that they had performed the task and wait for a reply on the outcome. On Mars, the reply will come after 10 minutes, but on the Moon, with a negligible delay, it will come almost immediately. So were we able to find any indication of differences in behavior between the two settings? Unfortunately not, but we used the feedback we received to refine the approach we used for the other ISEs that were presented previously. So what did we learn? Well, in the first ISE, most feedback centered around the game-like nature of the enactment. Participants were quick to notice the limits of the system, and there were, for example, some objects that were non-interactive, and seeing your hand intersect it without no effect immediately broke the suspension of disbelief. So for successive ISEs, we only included objects if those were interactive and reacted to the physics systems. What is then the potential of ISEs as an HCI method? The expectation is to use ISEs to draw transferable insights for the real world. However, one characteristic of the ISEs that we run is that they would all be extremely hard or outright impossible to run in the real world, because either the technology does not exist or because of ethical concerns that will make such studies unfeasible. When real-world validations are impossible, alternative measures that consider the extent to which the results of a study are consistent with its aim should be used as an indication of whether face validity has been achieved in lieu of ecological validity. In the domain of VR, this translates to the use of presence and other behavioral measures to understand whether participants are behaving in a manner that is adherent to what we would reasonably expect them to do if the scenario were real. How then to design an ISE? Here are some recommendations. First, define the possible future that the ISE will focus on. This will give us a framework in which to define the limits and affordances of that future. One thing to consider is that when we speculate about the future, depending on how distant the future is, we are not only speculating about a new technology, but also about everything that surrounds it, which could also play a role and affect the potential validity of the scenario. There is the risk that we can get it very wrong or not close enough. We also recommend the use of storyboarding. To highlight the sandbox nature of ISEs, we explicitly supported interaction that would allow participants to either ignore or not otherwise engage with the logic of the scenario. Thank you all for listening so far. If you wish to learn more about ISEs, please refer to the paper. And with that, I would like to thank all my co-authors, everybody who took part in the experiments, and the funding agencies who made this work possible. Thank you.